Hello everyone, welcome to Reactify Labs. Today we will talk about another design pattern, another behavioral design pattern rather, and it is called chain of responsibility pattern. Okay, let's write it down. Chain of responsibility pattern. Okay, and the technical definition for this is chain of responsibility pattern is a behavioral design pattern that lets us pass requests along a chain of handlers. Okay, so there will be a chain of handlers. The request will come and pass from here to here to here to here. And upon receiving a request, each handler decides either to process the request or to pass it to the next handler in the chain. So each handler, let's say this is 1, 2, 3, 4. So the request will come and this handler will decide whether it is able to process it or not. Okay. If yes, then okay. Otherwise, it will send it to the next one. Okay. Um, the perfect real life example of this would be, let's say you have a staff engineer, you have a senior engineer, you have a mid-level engineer, and you have a junior engineer. Okay, actually okay, the order should be the other way. Okay, what happens is, let's say a coding bug comes up, minor bug, code minor bug, a minor bug comes up, and it's a very easy bug, so all of them can solve it, right? But if there is a major bug, very critical, that only the staff engineer can solve. Or if it is something, let's say something between major and minor, which the staff engineer and mid-level engineer can solve. Okay, so it will be like this: if it's a minor bug and if the request comes to staff engineer, he will solve it. Okay, or if it comes to junior engineer, he will also solve it, right? Then this minor bug goes to whomever, they will solve it. This major bug, if this major bug comes to a junior engineer, what this will do is the junior engineer will check if it can solve it or not. It will see that okay, it cannot solve it, the junior engineer cannot solve it, so he will send it to the next higher in command, mid-level engineer. Mid-level will see that okay, it's beyond his capability also, so he will send it to senior engineer. Senior engineer will see and realize okay, it's something only staff engineer can solve, so he will send it to staff engineer, and staff engineer knows he can solve it and he solves it. So see, once a request comes here, one type of request comes here and it gets solved. Wherever it goes, it gets solved. But there is another type of request which, if first goes here, it will be transferred to here, then here, and then it will be solved. The other thing is, instead of here, if it comes directly here, this will be solved. Or if it comes here, then again it will be transferred to here and then it will be solved. Okay, so we always don't know where a request should go, so we should have a mechanism to uh, make the request go to its specific location where this can appropriately be handled. So this is all the concept behind um, chain of responsibility pattern. Okay, so let's start, or let's see this with like how this is implemented with a simple explanation of a logger. Okay, so there is a logger which logs whether a log is information log, debug log, information log, debug log, or error log. Okay, so let's see. If let's assign them a level. Info log is 1, debug is 2, error is 3. Then info if there is a log which comes at info, it knows it can log it. If a info level log comes to error, then error can also log it. But if an error level log comes to error, it will be logged, but if it comes to info, it will go to debug, and from debug it will go to error, and then only it will be logged. Okay, so this is what I'm trying to show here. So what we will do is we will have an abstract class called logger. Why abstract class? Because we will have some common functionalities. We will have an abstract class called logger, and we will have different levels of the logs. Info is 1, debug is 2, and error is 3. Correct? Okay, then there will be a level, int of level. We have to set this level. Okay, and also we have to set a next logger also. So there will be a logger object as well. Logger space logger, and there will be a set next logger. And this set next logger will have a logger object. I'm not focusing on the syntax and semantics, so just assume that it's correct. Okay, so instead of naming it logger, we will name it next logger, and this set next logger will set the value of next logger with logger. Okay, correct. This thing is set up. Now there will be one more function, which is log message, obviously. So what this logger will do is it will check for this log message function, and it will be like this. Just a second, I'll write it here. So there will be a function called log message, and if the message is there, it will have a level, and along with this a message. So what the log will do is it will check if current level, whoever got this message. So if this dot level is less than level or less than equal to level, only then this will print the message. Print message. Or instead of print, just like write the message. Okay. If it is like this, only then it will write the message. If not, okay, or even if it is there, okay, once someone did it, it's similar to like if the junior engineer resolved the bug, it will go to the senior engineer to verify if it was all right or not, and the senior engineer will send it to a staff engineer. Similarly, it will be like this. So there will be, if the next logger is also capable of handling it, or and if the next logger is there, if next logger is not null, means the next logger exists for the current level, then what it will do is this next logger will recursively call this log message. This log message will again be called this log message. Okay, and this will also be called with level and message, because we know that the level of different loggers are different. Okay, got it? So this is it. Now we will have different classes for each logger. We will have an info logger class, we will have a debug logger class, and we will have an error logger class. Each of these will have nothing, it will have just their constructors, and the constructor will just set the level in each of these. And then there is one thing which we are using here, write message. This write message we have to just write. Okay, each of these will give their own identity, right? That this log was written by info logger, this log was written by debug logger. So each will have their own implementation of write. So that's it. This skeleton is ready. Now what we are going to do is we are going to see how our client is going to use it. So the client is going to do this. Client will have an error logger, and the object is called error logger. Logger will have another object called debug logger. Logger will have another object called info logger. All these loggers will be created and their constructors will be used, right? New error logger, similarly new debug logger and new info logger. I'm not going to write it. And we know the level goes like this: info to debug to error. So we know that this info logger dot set next. See here, set next logger. We are setting the next logger, right? So info logger dot set next logger. This will set what? This will set which one as the next logger. For info, the next logger value is debug logger. So it will set debug logger. And for debug logger, it will set the next logger as error logger. And this error logger is the highest, so we know that there is nothing on top of it. So for error logger, the next logger value is null. Now what happens is, for the info logger, let's say we get the message info logger dot log message. If log message is coming to info logger with, let's say, the level as 3 and some message. So what it will do is, this log message will come, this will come here, this will come here, and this will call this log message. See, for info the level is 1. So for info this level is set to 1. It will check the level which is the, just a second, the level of info log is not the same as this level. Okay, sorry, yeah, the message has level 3. Info log sees that, okay, this info log has level 1 and the message has level 3. So the info log is going to log it, obviously. So the info log will log the message. Okay, and then if you see here, it will call the next logger. It will call the debug logger. So the debug logger sees that debug logger has the level 2 and it will call it again. It will write the message. So again, the message will be written here and debug logger will call error logger. So error logger will also write it. Let's say another thing comes up like debug logger dot log message. Something comes up like this. Debug logger dot log message 1 comma message. So debug logger knows that its level is 2, right? For debug logger, if you see, the level is 2 and this, the message which has come has level 1. So debug logger will see that, oh, this dot level is less than equal to 2 is not less than equal to 1, right? So it will not print it and it will send it to error logger. The error logger will also see that, okay, it cannot also not print it because 3 is not less than equal to 1. It is not right? So it will also not print it and hence it will not be printed. This log message will not be printed if it goes to debug logger. So the recommendation is always to start with the lowest level, info logger dot log message. It will always start with this one. So there is always a chance that one of the levels will accept it. If we do something like this where we start with a higher level, then it is possible that message printing may get missed. Okay, so I hope this is clear. This is what the chain of responsibility pattern is. So we have a chain of responsibilities. We have formed a chain of different loggers here. We have formed a chain of engineers there. And whenever a bug comes up or the logging responsibility comes up, depending on which logger can handle the request is transferred to the appropriate logger and it gets resolved. Okay, I hope this clears the chain of responsibility pattern, and that's it. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.